Hello, everyone. Thank you for joining us for today's Michigan Engineering Online and Professional Education, Computational Machine Learning for Scientists and Engineers informational webinar. My name is Dejanae Beaver, and I'm a program manager for Michigan Engineering Online and Professional Education. A little bit of housekeeping before we begin. You are welcome to ask questions throughout the presentation by putting them in chat or raising your hand via Zoom. There will also be a dedicated question and answer period following the presentation. And now let's welcome today's speaker, Raj Rao. Raj Rao is an associate professor in the Department of Electrical Engineering and Computer Science at the University of Michigan. He received his master's and PhD in electrical engineering and computer science as part of the MIT WHOI Joint Program in Ocean Science and Engineering at MIT. Raj works at the interface of statistical signal processing and random matrix theory with applications such as solar, radar, wireless communications, and machine learning in mind. And now I'll turn it over to Raj. Welcome.
Thanks for the intro. Thank you all for joining the webinar too. I wanted to spend a few slides and maybe the next 10 to 15 minutes previewing a little bit of what this course starting this January is about. So just to kind of, connect it to some of the stuff that's been in the news, you might have seen images like this, which are deep fakes. This is a very early New York Times article from 2018 that, gave a quiz as part of the write-up where they said there's this guy on the left and a guy on the right, and we had to guess which one of these faces is fake and why. I've often shown this slide in various settings, including in classrooms, and there are some folks who point out that maybe the guy is fake because, some of the reasons they've given is if he looks too good looking to be real. Some folks have kind of remarked that the woman seems fake, maybe because her eyes seem a bit, in their mind, a bit too green or too unrealistic. In this particular case, it turns out that both of these images actually are fake. So it's slightly a trick question in that sense. I want to just show you an example of just a demo, just to show you how easy it is to generate these pictures in that context. So this website is called This Person Does Not Exist. And every time you reload this website, it basically generates a fake face. And each of these are generated by passing as an input to the neural network face generator program. In this case, I think 512 or 1024 random numbers that are drawn from a Gaussian distribution, and the output of it is basically a face. So every time I press reload, I get a new face because that corresponds to a new set of random numbers that generate that face according to the neural network that was trained for it. So here's another demo I want to show you of called inpainting, where the basic idea of inpainting is you take an image and maybe you draw something across it. Let's say you put an X in this case, and then you apply a neural network model. And when you apply the model, you notice that essentially it kind of fills it in. It looks really good. So if you kind of remove the mask and you show what it looks like, the results are, pretty amazing because the neural network has figured out what is in between the gaps and it fills it out. So at a high level, what we're trying to do in the course is when you, let's say, see examples of this, like inpainting or deep fake generation or other examples of generative AI, and you open up a paper, you'll see examples of neural network architectures that look something like this. So this is an example of an image inpainting network that was taken from one of the papers listed at the bottom of the slides. And the goal of the course is, by the end of the course, you should know how to read these papers, to be able to implement these neural networks, and to be able to evaluate them in a way that lets you understand their strengths and their weaknesses. So from the point of view of this course, these are a couple of the three outcomes that we're hoping and we're confident that learners will accomplish, which is if you take a new ML paper, you should be able to read it and understand the terminology and understand what was done and how. You should be able to create machine learning pipelines for applications of your choosing that take as a starting point the input processed and packaged in a certain way and outputs governed by what you're hoping the application does. And finally, you should be able to critically analyze your ML model for its strengths and weaknesses and come up with follow-up requirements to improve it. Um, the last part, especially why we want to understand the pros and cons of the model and where it works well and where it doesn't, is particularly important because in many applications of neural networks, including in modern examples like ChatGPT, when we think of ChatGPT 3.0 to 3.5 to 4.0 to maybe someday 5.0, each iteration, if you would, is trying to overcome some weakness of what the previous version does not quite do adequately. So one particular set of systematic way we want to do this is look at model and look at what it gets right. So in this context, you'll notice there is an object detector in a computer vision type of neural network, which in the top left column correctly identifies a school bus as being a school bus. But then you notice that if I take the school bus and I rotate it in weird ways, for example, a school bus that is, I hope never quite happening, but in a deformed crash-like situation, you notice the predictions of the neural network are in column B, it says it's a garbage truck. In column C, it thinks that this flipping over school bus is a punching bag, whereas in column D, it thinks it's a snowplow. Now, a human would certainly recognize a school bus in each of the situations B, C, and D, but the neural network doesn't quite. You notice the same behavior for the scooter at the bottom left. The computer vision algorithm that's trained for the scooter being the way it is recognizes it with about 99% self-confidence. But when the scooter flips around, you notice the predictions are parachute, bobsled, and parachute, which are definitely not something a human would do. So the perspective here is once we're able to get via the kinds of things you learn in the course, how to get predictions of the form in column A that work well when images are normal, you'll have the language and terminology for thinking about how do I identify shortcomings in the data set corresponding to columns B, C, and D, and what's needed to be able to train the algorithm or generate the data set to be able to be more robust for the kinds of real world situations where your algorithm doesn't quite work as well as you'd hope for it to work. These particular things in terms of creation of the data sets are also important for human systems particularly because if the data set has certain biases in it, they get reflected in the ML algorithm, and it's important to understand how we can, properly look at the output of the ML algorithm and uncover biases in the data set that we might want to debias to make sure that the ML algorithm is fair, equitable, but also performs in a way that is representative of real world scenarios. Okay, so here's an example of a data set that was kind of famous in the ML algorithm because I think Amazon used a data set from maybe the 80s to try to figure out from resumes who might be good candidates to hire. In the 1980s, there weren't many, women in computer science in the early days of CS as an independent field of study. So that data set was biased by not quite having representative samples of what's happening in 2025 or 2024 or even earlier when this discovery was made. So a consequence of that is the algorithm works very well in the data set it was trained for, but when it's applied in the modern context, there are thankfully way more women now in computer science departments than they were in the 1980s. And the algorithm systematically does not quite select these, promising and talented women for interviews, which is, of course, bad from the point of view of the applicant, but also even worse from the point of view of the company because it misses out on the kinds of applicants that Amazon really would like just because the data set itself is biased. So going through that pipeline of developing the model, training the model, and deeply understanding how the data set affects its output and what we need to enlarge or improve in the data set will allow you to customize and tune and refine these algorithms for the kinds of settings you have in your application. So generally speaking, even the title of the course, in terms of what we've labeled it, is computational ML. Computational ML is referring to the aspect that many of these algorithms have to be implemented on a computer in a computational manner. When we say it's for scientists or engineers, our focus really is where thinking about these algorithms and the presentation of the algorithm is that you should be able to take the algorithms and apply it for your domain to make the kinds of applications that are interesting to what you're expert in already. So in our mind, we have that someone can take this course and apply it to mechanical engineering, for example, to make better car design principles or better brakes, or other kinds of things that a mechanical engineer might be interested in. Or you could take some of these algorithms and combine it with your skills in biology, chemical engineering, or whatever else you are expert in ways that allow you to harness the full power of AI and ML for your application domain and to be able to see successes in the way that you define it there. So here are a couple of the course objectives. As you know, just to recap, is by the end of the course, our goal is to equip you with the fundamental understanding of data science and machine learning via these networks, knowing what, how, when, and where to use these methods, and specifically when do these methods not work, and when they do not work, how to fix them. We want you to be able to read papers on the state of the art and understand all the jargon, and to be able to demystify some of what maybe seems confusing before you dive into this technical matters that we'll talk about throughout the course. Our particular focus and the way we'll go about it is rather experiential, which means you'll be learning by coding rather than watching me code. And via your code, you'll kind of learn how these different components come together, and you'll see how when these components come together, the application is really quite magical. So for example, by the end of even module 1, when you start the course, you will have trained a neural network to distinguish between handwritten digits in your own handwriting between a 0 and a 1. And there's many such applications throughout the course that let you learn things experientially, but also code it up in the way that's important and critical for these ML AI algorithms that are out there and already doing well. An important component of this really is this, what we keep referring to as computational thinking, which is linking math, which is really the guts of these algorithms, to coding or programs and vice versa, and being able to debug code when things are not going well. Here are a couple of the topics that we'll cover. We'll start off with binary supervised classification, move on to multi-class classification, then go into deep neural nets, do some examples with deep neural nets so you can get practice on the whole pipeline, work with generative model, logistic nets, convolutional nets, and then give you a couple of different ways in which you can program with deep nets using Keras TensorFlow or PyTorch. We'll supply many practice examples so you can keep getting better and better at these concepts, and we'll give you opportunities as you wish for one-on-one discussions with me and the staff on connecting these concepts to your own application in ways that are informed by your growing understanding of these and your curiosity of how to take these concepts you've learned about into the kinds of applications that you're passionate about yourself. Okay, so that's basically all I wanted to share. I wanted to leave some time open for questions, so we can talk about what you're interested in or the kinds of things that you, any other doubts or comments you have about the program. That's all I have for this. Tijana, do you want to take over?
Yes, if anybody has any questions, you can either A, unmute yourself, or B, throw them in the chat and I can read them aloud.
Yeah, it's a great question, Sydney. So Sydney's question is, can you talk about how you will support the learners through the course? The main idea is one of the main technologies we use for you learning these materials is using an interactive textbook platform that I was a co-inventor of along with a former student. The textbook, the interactive computational textbook, goes through a combination of code and concepts where every time you learn something, you're asked to program it, and there is an autograder on the cloud that checks for it. So typically when learners go through it, the basic idea is you're working your way through the concepts, doing the different materials, and as you get stuck, you can schedule office hours. We'll give a scheduling link so that a couple of times throughout the day and through the weekend, there are people available that you can talk to, or you can email me or the support staff to ask follow-on questions. But the format of the course is asynchronous, so you can work at your own pace, and there will be synchronized, meet on demand opportunities for you to connect with the teaching staff to be able to resolve any difficulties you have as you go through it. I think one component I'll mention is everyone going through the course at some point, we really do want that kind of conversation where, if there's a doubt that comes up or you're curious about something, then we hope that learners take that opportunity to schedule one-on-one calls and talk about it so that we can combine the best of asynchronous learning, which is really working at your own pace, with the best of in-person learning, which is being able to reach out whenever you're stuck. Okay, so another question is, can you talk a little bit about the pre-test requirements? Um, so as part of the application, when you apply, you're given a screening module, the instructions to screening module. The screening module will basically go through an introduction to a programming language that we'll use called Julia, and also a little bit of matrix math, which is like maybe linear algebra 101. It's important that one does that because really coding machine learning involves linking math of the kind that is in linear algebra with code, which could be in Python, Julia, or any other language. So it's important that you have some facility with it, right? We're not expecting you to know everything about it. That's the point of the course for us to teach you, but it's important that at least the style in which I'm teaching it is a match for your learning style, and also the kind of math that we're talking about and certain concepts in matrix math, at least the way that I've developed it from scratch in those modules, you feel you're comfortable with. So once you're done with the intro to Julia and the intro to matrix math module, at the end of the intro to matrix math module is a link to complete your registration and pay. And once you've done that, you're officially registered. So if you've got to the end of the intro to matrix math, I feel confident that you have what's necessary to be able to link math and code in the way that this course was designed, and that we can support you through your learning journey. So it's important to do the screening stuff to get a feeling also for the textbook platform, for the way in which we're integrating the two, and also whether it's a good fit for how you learn. So another question is, can we apply what we learn right away? I think it depends a little bit on the kind of application you're doing, right? I think our goal and the way that the course materials were defined was by the end of every module, you can apply it right away for something. Now, it might not be the most complicated example in the world, right? So it's not like at the end of module 1, you'll be able to make your own chat GPT, but you'll definitely be able to do something. So by the end of module 1, you will be able to write on your screen and recognize 0 and 1 using the same technology and an appropriate data set. If it's available, you will be able to create an algorithm that recognizes not just 0 from 1, but also 1 from 2. You can also use the same algorithm to recognize cats versus dogs within the kind of construct that the first algorithm refers to in ways that we'll make clear. It might not be the best algorithm, but you'll know right away how to kind of set up the pipeline to do something half decent. And then throughout the course, you'll be able to go back and visit the same application with increasingly more sophisticated algorithms so that if, let's say, at the end of module 1, you were able to recognize correctly whether it's a cat or a dog with, let's say, 45% accuracy, by the end of module 8, you'll be able to recognize a cat versus dog with, let's say, 90% accuracy, right? So you'll be able to apply it, but it might not be the best algorithm, but you'll have a pathway through the successive modules to seeing and also witnessing the improvement as the model architectures get increasingly more complicated. I think a comment I'll just add related to this is, since the focus of this is so experiential, it really is very important to take one's time in learning. So the course, I believe, starts sometime in mid-Jan, and these modules are released once every week or 2 weeks. The deadlines, so to speak, are very soft in the sense that our goal is really to support you as you work your way through it. So it's important that our learner takes their time and reaches out whenever they're stuck, at whatever point they're stuck, rather than focusing on finishing them. Because really, once one understands the algorithm deeply and one knows how to code it, you really can, from the end of module 1, start immediately applying it to a data set of your choosing, and then making it increasingly complicated as the course goes on. So that's what's nice about an experiential learning kind of experience, I think, is you can kind of see, right? You don't have to wait too long to see that it's actually working because the code is in front of you and you're playing with it almost from like minute one.
All right, if there isn't any more questions, then Raj, I think we can close out.
Okay, maybe we'll give it a minute. If there's any other questions or comments, folks, we're happy to answer it. Otherwise, thank you for joining us.